Hey, Professor Capps, it's Michael James here again from your chemistry class. Hope your Wednesday night is going as wonderful as mine is. I'm doing a little experiment here with pennies and showing how copper oxide can be removed with the use of an acid and also a salt when they're mixed together. Um, so what I've done for this experiment is that I've ran through it already once because after watching the video I learned that it was going to be quite time consuming. So I'm going to run it through once for you so that you can see what I've done, but I'm also going to use the results from a previous run on the experiment. So anyways, got some vinegar here. I'm going to pour it into my bowl. And I've got a clear bowl here. Makes any sort of observation a little bit easier if you can see through. All right, so I got some vinegar in my bowl, and I've got some salt here. So I'm going to put some salt in there, and you'll notice that the salt doesn't dissolve immediately. It needs some sort of mixing to make sure that it dissolves. So when I did this the first time, it took at least 20 seconds of stirring for the salt to be completely dissolved in the vinegar. And we're slowly getting there. And I'm not sure if it's taking longer because these crystals are a little bit larger than your average salt. So I'm going to bring this bowl up into the camera so you can see. We're looking at mostly an aqueous solution now. I don't have any precipitate down in the bowl. All right, so I've got some pennies here, old and dirty as you can probably tell. And then I've also left out a penny to use as my control so that we can analyze the color. No, I don't observe anything immediately. However, after about maybe a minute and 30 seconds of being dissolved in the first round of the experiment, I did notice a lot of bubbles. And I think that they were more so concentrated on the older copper coins, and I believe that's due to more copper oxide. I'm not exactly sure how copper oxide or how long it takes for that reaction to take place. I know that the atoms will bind with other atoms to create molecules, and oftentimes it's the copper binding with the copper, but I believe that the copper binds with oxygen molecules from the air to create this dirty, dingy appearance over time. Now, I'm not sure how long it takes for this reaction to take place, as I stated, but it definitely happens because got some dirty pennies. All right, I'm going to put this aside. I'm not seeing any sort of bubbles just yet. Maybe as I compare some of the results from the first experiment, I'll get something and I can show you that on the camera. But as of right now, I'm not getting anything. All right, so now I've got, this is a copper coin from the first run. Now I don't know how clear that's going to be for you. Maybe I'll put these up side by side just so that you can see what I'm seeing. The camera on this MacBook isn't the greatest, but maybe we can get some definition if we focus it a little bit. Anyways, my right, the one that's moving, is the one that underwent the reaction. Maybe you can't see, but my observation is the one on the right definitely looks much cleaner. It's not as dingy. It's brighter. And I was hoping that these could sit out long enough to to undergo another part of the reaction where the copper oxide is removed, and that allows the copper atoms to bind with both chlorine from the salt and then oxygen from the air to form this blue-green color. Now, I'm not seeing that yet. I'm seeing it in spots, but the whole coin is not undergoing a complete color change. All right, so now that I've ran through that, let me see. I got some bubbles in my bowl going on the pennies, but I'm going to run through what happened. So the copper coins look dirty before we clean them in the salt and vinegar mixture. So the copper of a penny is composed of many copper atoms. However, sometimes atoms of different kinds join together to make molecules, and I kind of discussed this previously. But in this case, the older coins have had the copper atoms combine with oxygen atoms from the air to make copper oxide. And copper oxide gives an appearance of dull and dirty. So when we placed the pennies in the salt and vinegar concoction, the pennies became cleaned, or at least they appeared to be cleaned. What's actually going on here is a chemical reaction that's driving this physical change in color. So copper oxide dissolves in a mixture of a weak acid, which in this case we used vinegar, and salt. And the vinegar reacts with the salt to remove the copper oxide from the pennies. So a good indication that there is a chemical reaction taking place is the presence of bubbles on the pennies once they're dissolved in this solution. Now, I'm not exactly sure, but I predict that the bubbles are actually hydrogen gas being released. And also, afterwards, we noticed that some of the pennies, once they were drying on this paper towel that I have down here, that they turned a blue-green color, because once the copper oxide layer is removed, it's easier for the copper atoms to join with oxygen from the air and the chlorine from the salt. And this is going to create a blue-green compound called malachite. All right, thank you.